how it's supposed to feel.
Microservices represent an architectural approach, where an application is broken down into multiple small, independent services, each with a specific functionality. These services are autonomous, communicate with each other, typically through APIs, and can be developed, deployed, and scaled independently. Unlike monolithic architectures, where all functionalities reside in a single application, microservices allow for greater flexibility and scalability. This modularity makes it easier to adapt to changes, implement new features, and fix bugs, all without affecting other services. Microservices offer a range of benefits that make them a popular choice for modern software development. Firstly, they provide scalability, allowing individual services to scale based on their specific demands rather than scaling the entire application. This leads to efficient resource utilization. Secondly, microservices enhance resilience. If one service fails, it doesn't bring down the entire application. This ensures higher availability. Thirdly, they promote faster development cycles. Teams can work on different services simultaneously, leading to quicker releases. Moreover, microservices support multiple technology stacks, giving developers the freedom to choose the best tools for each service. Lastly, they facilitate easier maintenance and updates, as changes to one service don't affect others.
While microservices offer numerous advantages, they also come with their set of challenges. One of the primary challenges is managing inter-service communication, as the number of services grows, ensuring efficient and reliable communication between them becomes complex. Another challenge is data consistency, with each service potentially having its own database. Maintaining data consistency across services can be tricky. Service discovery, or the ability for services to find and communicate with each other, is another area that requires careful planning. Additionally, deploying and monitoring multiple services can be more complex than dealing with a single monolithic application. Lastly, security concerns arise as you now have multiple entry points into your application, each of which needs to be secured.
The microservices architecture is supported by a variety of tools and technologies designed to streamline its implementation and management. Docker, for instance, provides containerization, allowing each service to run in its own environment, ensuring consistency across development, testing, and production. Kubernetes, on the other hand, is a powerful orchestration tool that manages and scales containers. For inter-service communication, tools like Rabbit or Kafka can be used for message passing. API gateways, such as Nginx or Zool, handle request routing, composition, and rate limiting. Service mesh solutions like Istio add an extra layer of control, providing traffic management, security, and observability. Monitoring and logging tools like Prometheus and ElkStack are crucial for keeping an eye on the health and performance of microservices. These tools, combined, create a robust ecosystem for building and managing microservices effectively. Microservices have been adopted by numerous organizations, from startups to tech giants, to address various challenges and achieve specific goals. For instance, Netflix transitioned to microservices to handle its massive scale and ensure high availability. Their microservices-based architecture allows them to deploy changes multiple times a day without affecting the entire system. Amazon, too, moved from a monolithic to a microservices structure to support its ever-growing diverse operations. This shift enabled faster feature releases and better scalability. Spotify, with its focus on providing personalized music experiences, leverages microservices to manage user preferences, playlists, and recommendations independently. These real-world examples highlight the flexibility, scalability, and resilience offered by microservices, making them a preferred choice for many modern businesses. Implementing microservices effectively requires adhering to certain best practices. Firstly, ensure that each microservice is single responsibility, focusing on one specific function. This promotes clarity and ease of maintenance. Secondly, use APIs for communication, ensuring that services are loosely coupled and can evolve independently. It's also crucial to implement centralized logging and monitoring to keep track of service health and performance. Automated testing is another essential practice, ensuring that changes don't introduce new issues. For data management, consider using the saga pattern to handle long-running transactions across services. Implementing an API gateway can help manage requests and aggregate responses from different services. Lastly, always prioritize security by implementing authentication and authorization mechanisms and regularly scanning for vulnerabilities. By following these best practices, organizations can harness the full potential of microservices while minimizing potential pitfalls. The cloud and microservices go hand in hand, complementing each other to offer scalable and efficient solutions. Cloud platforms provide the infrastructure and tools that make it easier to deploy, manage, and scale microservices. With cloud services, organizations can quickly provision resources, ensuring that their microservices have the necessary compute, storage, and network capabilities. Cloud-native tools like Kubernetes facilitate container orchestration, ensuring that microservices are resilient and can handle varying loads. Additionally, cloud providers offer managed services for databases, messaging, and more, which can be seamlessly integrated with microservices. The pay-as-you-go model of the cloud also aligns well with the scalability benefits of microservices, allowing organizations to optimize costs. In essence, the cloud provides the foundation on which microservices can thrive, making it an integral part of modern software architecture. Security is paramount in any software architecture, and microservices are no exception. With multiple services interacting, there are multiple points of potential vulnerability. Firstly, always secure inter-service communication. Using protocols like HTTPS and implementing mutual TLS can ensure data integrity and confidentiality. API gateways can be used to enforce authentication and authorization, ensuring only legitimate requests access the services. Another crucial aspect is service isolation. By running services in containers, potential breaches can be contained, preventing them from affecting other services. Regularly scanning for vulnerabilities in code and dependencies is also essential. Implementing a centralized logging and monitoring system can help detect and respond to security incidents promptly. By prioritizing security in microservices, organizations can ensure that their systems remain robust and trustworthy, even in a distributed environment. Microservices continue to evolve, and several trends are shaping their future. One significant trend is the adoption of service mesh technologies like Istio and Linkerd. These provide enhanced control, security, and observability for microservices interactions. Another trend is the increasing integration of AI and machine learning with microservices, allowing for smarter and more adaptive systems. The rise of serverless architectures, where cloud providers manage the infrastructure, is also influencing microservices development, allowing developers to focus solely on code. Additionally, there's a growing emphasis on developer experience, with tools being designed to simplify microservices development, deployment, and management. As businesses recognize the value of real-time data, event-driven architectures are becoming more prevalent, with microservices reacting to events rather than following a request-response model. These trends highlight the dynamic nature of microservices and their continued relevance in the tech landscape.
The future of microservices looks promising, with several advancements on the horizon. As edge computing gains traction, we can expect microservices to play a pivotal role in processing data closer to the source, reducing latency. The convergence of IoT and microservices is also anticipated, with microservices powering numerous IoT devices and applications. Quantum computing, though in its infancy, might influence microservices, offering unparalleled processing capabilities. The continuous evolution of cloud platforms will further simplify the deployment and scaling of microservices. We can also expect more standardized practices and tools to emerge, making it easier for organizations to adopt and manage microservices. With the increasing importance of sustainability, eco-friendly microservices, optimized for energy efficiency, might become a focus. The adaptability and modular nature of microservices ensure that they will remain at the forefront of technological advancements.
While microservices have gained immense popularity, it's essential to understand that they aren't a one-size-fits-all solution. Several alternatives might be more suitable depending on the use case. Monolithic architectures, where the application is built as a single unit, can be more straightforward for small applications with limited complexity. Serverless architectures, where cloud providers manage the infrastructure, allow developers to focus solely on writing code, eliminating the need for server management. Another emerging trend is the use of graphical, which offers a more flexible approach to data retrieval compared to traditional REST APIs. There's also a growing interest in event-driven architectures, where systems respond to events rather than following the request-response model. While microservices offer numerous benefits, it's crucial to evaluate other architectural patterns and choose the one that aligns best with the project's requirements and goals. Microservices have undeniably revolutionized the way we design, develop, and deploy software. Their modular nature offers unparalleled flexibility, scalability, and resilience, making them a preferred choice for many modern businesses. However, like any technology, they come with their set of challenges. It's essential to understand when to use microservices and when other architectural patterns might be more suitable. The continuous evolution of tools, technologies, and best practices ensures that microservices remain relevant and effective. As we look to the future, it's clear that microservices, combined with emerging technologies like edge computing, quantum computing, and AI, will continue to shape the digital landscape. Embracing microservices and understanding their intricacies is crucial for any organization aiming to stay ahead in this rapidly changing technological world.